Hi friends, in this session we study about the algebra of limits. First I explain you the algebra of limits. It is if we have two functions, we are adding two functions, we are subtracting two functions, we are multiplying two functions, we are getting division of two functions. So these are called the algebra of limits. There are some other thing also. So here first let f and g be two real functions with common domain D. There is a common domain for both the functions. The domain should be same. Then the algebra of limits would be as follows. I have explained here in this chart. So first we see here we are taking let m x tends to a for f of x is equal to L. The limit for f of x at x tends to a is L, and limit for g of x tends to a is m we have. Now for first, here we see there are two sub process. Here in first you see that here is addition and subtraction, both we have given in one. So limit x tends to a for f plus minus g of x is equal to limit x tends to a for f of x plus minus limit x tends to a for g of x. It means if you have to find out the limit of summation of two functions, which is equal to the limits summation of the limits of two functions. If you have to find out the limits of subtraction of two functions, it is also the subtraction of limits of two functions should be equal for this. So and the second you see here, limit x tends to a for f into g of x is equal to limit x tends to a for f of x into limit x tends to a for g of x. Here you see, if you have to find out the limit for the product of two functions is equal to the product of their limit. Okay, so this we have to verify here. Now the third one you see x limit third one you see limit x tends to a for f over g of x is equal to limit x tends to a for f of x limit x tends to a for g of x. Here you see, if you have to find out the limit of the division of two functions, then it is equal to the division of their limits, where the limit in the denominator of the function should not equal to 0. Now you see the fourth one. If you multiply any function with a constant and we have to find out the limit x tends to a for k into f of x is equal to k into limit x tends to a for f of x. It means if you have to find out the limit of the product of the function and a constant is equal to the product of the limit and the constant, both are equal. Now the fifth one you see, if you have to find out the limit mod of a function, then it is equal to the mod of the limit. If you find out first limit and then we take the mod, it is also equal to first we mod the function and then find out the limit, both are equal. The sixth one you see limit, if you have to find out the limit x tends to a for f of x over g of x. There is a function and it is kind of composite function if you have to solve in a limit. So it is also L power m. So here we verify these all with an example. So first I take one example. First of all, we are taking f of x is equal to x square plus 3 and g of x is equal to x minus 1. So these two functions we have. Now you see in both the functions, you see what would be the domain for these functions. So f of x is equal to x square plus 3, which is a quadratic function, and the domain of quadratic function is R. It is a real number. Any real number we can put here instead of x. Here you see g of x is equal to x minus 1, which is a linear function, and the domain of linear function is also R. So here is the domain is common. So we have a common domain. We have a common domain. R here for both the functions, because this is the condition we have. The domain should be common for both the functions. You have to make any sort of algebra between the functions. Now we find out the limits of these two functions individually at x tends to 2. So we find out the limit for this limit x tends to 2 for f of x. We see what happens. So it is limit x tends to 2 for x square plus 3. So here we see it is equal to 2 square plus 3, which is equal to 4 plus 3. Now it is equal to 7. So we have got this limit, or this limit we say it is L. We are denoting this limit by L. It is our L we have got here. So this is our L we have now. L we have L is equal to 7. Now we find out another limit. Now we find out the limit for g of x. So x tends to 2 for g of x. So it is limit x tends to 2 x minus 1. For x minus 1 we have to find out this. Now we put this value to here. So it is 2 minus 1, which is 1. So this is our m. The limit of g of x we are putting n. So m we have 1 here. Now you see here we have got m also. So we have L and m now. Now we verify these all. The algebra what I have written here. Now we verify the first algebra, which has two parts. So first part we are verifying here. So first a part we are verifying here. So you see here what we have to verify. We have to verify that limit x tends to a for f plus g of x is equal to limit x tends to a for f of x plus limit x tends to a for g of x. Or we know already that the limit for f of x at x tends to a is L, and limit for g of x at x tends to a is n. So it should be equal to L plus n. So first of all we have to find f plus g of x function. So because f plus g of x is equal to f of x plus g of x. First we make this function, then we find out the limit for this. So f of x is x square plus 3 we have taken, and g of x is x minus 1 we have taken. It is x square plus x, and 3 minus 1 it is 2. So this is our function f plus g of x. F plus g of x. So this we have the function now. Now what we do, we'll explain here. Just a moment. I put one line here. Okay. Now we see what we have to do. We have to find out the limit for this. So limit x tends to 2 for f plus g of x, which is equal to limit x tends to 2 for x square plus x plus 2. So now we put this value to instead of x. So it is 2 square plus 2 plus 2. So we are getting here 4 plus 4, which is equal to 8. So we are getting here 8. So because we have taken this function x square plus 3 and x minus 1. So we are getting here x square plus x plus 2. So it is 2 square plus 2 plus 2. So we are getting a 4 plus 4, which is 8. So this is our limit for this function. And we have to prove that this limit should equal to limit x tends to 2 for a plus g of x should equal to L plus m. So we know it is 8, and L we know that it is 7. We have L is 7 here and m is 1. So it is 7 plus 1. So 8 is equal to 8. Now it is verified. Now the second part of first algebra, which is first B we see. Here we have to verify that limit x tends to a for a minus g of x should equal to limit x tends to a for f of x minus limit x tends to a for g of x. We know that the limit for f of x tends to a is L, we have assumed it, and limit for g of x tends to a is m. So it is L minus m. We have to verify this. Now first of all we have to make a function f minus g f of g of x. So first we make this function. So because f minus g of x is equal to f of x minus g of x. So f of x we know that x square plus 3, and g of x we know that x minus 1. If we simplify this, x square plus 3 minus x plus 1, x square minus x plus 4. So it is f minus g of x. We have got this. Now I put one line here for explaining this. Now what we have to find out the limit of these functions. So limit of x tends to 2 of f minus g of x is equal to, we know that this function is limit x tends to 2 is x square minus x plus 4. Got it? Now we will put these values here. So it is 2 square minus 2 plus 4. Here we see that 4 minus 2 plus 4. So here we 4 plus 4, 8 minus 2. So which is equal to 6. So this limit for f minus g of x tends to 2 at 6. So we see here, we put here a limit x tends to 2 for f minus g of x should equal to L minus m. This we have to prove that, and this limit we know that it is 6, and the limit for L we know the value of L is 7. Here we have proved here L is 7 and m is 1. So 7 minus 1 we have to put here. So it is 7 minus 1. So 6 is equal to 6. So second part we have verified here of first algebra. Now the second we see. Now we see the second algebra for this. So it is, we have to verify limit x tends to a for f into g of x is equal to limit x tends to a for f of x into limit x tends to a for g of x. And we know the limit for f of x at x tends to a is, we have assumed L, and this we have assumed m. So L into m should be equal to. So first of all we have to find out the function f into g of x. So we find out this first, because we know that f into g of x is equal to f of x into g of x. And we know that f of x is x square plus 3 and g of x is x minus 1. So now we simplify this. X square x minus 1 plus 3 x minus 1. So we get here x cube minus x square plus 3x minus 3. So this is our f minus g of x. We have got this. Now we find out the limit for this. So I put here, we find out the limit for this. So limit x tends to 2 for, just a moment, so we have therefore f into g of x is x cube minus is equal to x cube minus x square plus 3x minus 3. Now we find out the limit for this. So we get here limit x tends to 2 for f into g of x is equal to limit x tends to 2 for x cube minus x square plus 3x minus 3. So it is limit, now we put 2 instead of x here. So 2 cube minus 2 square plus 3 into 2 minus 3. So we get here 8 minus 4 plus 6 minus 3. So 8 plus 6 is 14 and it is minus 7. Minus 4 minus 3 is minus 7. So we get here 7. So 7 is the limit for f into g of x at x tends to 2. So now we have to verify here limit x tends to 2 for f into g of x is equal to L into M. This we have to verify, and this we know that it is 7, and L we already know that 7 and M is 1. So 7 is equal to 7. So it is also verified here. Now we see the third one for this, which is limit. We have to verify limit x tends to a for f over g of x is equal to limit x tends to a for f of x over limit x tends to a for g of x. It means L over M, where the condition M is not equal to 0. So it is always the condition in the resistance. So first of all, we have to find out the function f over g of x. So we find out the f over g of x, because f over g of x is equal to f of x over g of x, and f of x we have x square plus 3 over x minus 1. So now we find the limit for this. Limit x tends to 2 for f of f over g of x is equal to limit, implies to limit x tends to 2 x square plus 3 over x minus 1. So now we put these values here. Instead of x we put 2. So it is 2 square plus 3 over 2 minus 1, which is 4 plus 3 over 1, so which is 7. So now we will prove this. Here we have to prove, here we have to verify that limit x tends to 2 for f over g of x is equal to L over M. So we know that this limit is 7 and L is 7, we know that, and M is 1. So it is 7 is equal to 7. It has been verified now. Now we have to verify that limit x tends to a for k into f of x is equal to k into limit x tends to a for f of x, which is equal to k into L. So we see this fourth one here. Fourth, we have to prove that limit x tends to a for k into f of x is equal to k limit x tends to a for f of x, it means if we multiply the constant with the limit, it is equal to the function which already has been multiplied with a constant we are getting out the limit. So first of all we have to find out kf of x. We are taking k is equal to 5 here. So for getting kf of x, because 5 into f of x is equal to 5 into x square plus 3, which is equal to 5x square plus 15. So now we find out the limit for this at 2. So limit x tends to 2 for 5 f of x is equal to limit x tends to 2 for 5x square plus 15. So we could say that it implies 2. So we put here 2. So 5 into 2 square plus 15, which is equal to 5 into 4 plus 15, which is equal to 20 plus 15, and which is equal to 35. So the limit is 35 here for this. And now we have to prove that it is k into L. Here we know that k is 5 and L is 7. So we have to verify this here. And now we have to verify limit x tends to 2 for 5 into f of x is equal to 5 into L. So we know this, it is 35, and L we know that it is 7. So 35 is equal to 35. We have proved this one. Now the next you see here, so the limit x tends to a for the mod of f of x is equal to mod of limit of f of x at x tends to 2. So it is the mod of the limit also. So here we have to prove that. Now in the fifth you see that we have to verify limit x tends to a for f of x mod of f of x, and we have to prove that limit x tends to a for f of x and its mod. We are taking whole mod, which is L. But here we are taking g of x instead of f of x, because the g of x is x minus 2, and we are taking the limit at minus 2. X tends to minus 2 we are taking. So here I put it down. Limit x tends to minus 2 for g of x mod of g of x. We have to find out. So we see what happens now. It implies to limit x tends to minus 2, which is x minus 1 mod of. So you see here, if we put these values, we get it is minus 2. So we put here minus 2 minus 1. So we get here mod of minus 3, which is 3. Now we find out the limit of first. We take different color here. So limit x tends to minus 2 for x minus 1. We have to find out this. So we get here, if we put here minus 2 minus 1, so we are getting minus 3 mod of minus 3, which is 3. So this also has been verified now. Now we see the last one. We are getting 7 1 now. We verify this. We have to verify limit x tends to a for f of x to the power g of x is equal to L to the power n. So here we first find out the function f of x to the power g of x. So because f of x to the power g of x is equal to x square plus 3 to the power x minus 1. This we have. Now we will find out limit for this. Limit x tends to 2 we are taking here. F of x to the power g of x is equal to limit x tends to 2 x tends to 2. So here x square plus 3 to the power x minus 1. So now we put 2. on both the function. It is a composite function, we know that. So it is 2 square plus 3 over 2 minus 1. So we get here 4 plus 3 power 1. So we get here 7 power 1, which is 7. So it is 7 now. So here we know that already. L is 7 we have, M is 1. So 7 power 1 is equal to 7. So we have verified this also. So in this session we have studied algebra of limits. Thank you.